All right, next problem is the perimeter of a triangle is 25 inches. Well, I'm going to draw a picture of a triangle. Doesn't say what kind of a triangle, so I'm just going to draw any old triangle. And we know that the perimeter is 25 inches. And I know that perimeter means the distance around the outside. Now I changed this just a little bit. Instead of calling this side 1, I changed it to side A is 6 inches longer than side B. Side C is 5 less than twice the length of side B. I didn't want to call them side 1, 2, and 3. I thought that was confusing, so I switched it to A, B, and C. What are the lengths of each of the 3 sides? So we're going to call this side A. I'm just picking one at random, side B and side C. Well, I know if I add up all the sides that equals 25, so I'm going to say A plus B plus C equals 25. I think you would agree with me. That's how you find the perimeter. Now this is a pain in the neck because we have 3 different variables that are unknown here. I mean, there's a bunch of possibilities of what A, B, and C could be. A could be 10, B could be 10, C could be 5. A could be 7, B could be 10, and C could be 8. I don't know what A, B, and C are, but I do know this. I am told that side A is 6 inches longer. 6 inches longer than something. 6 inches longer than what? Oh, it's 6 inches longer than side B. So I know that. I also know that side C is 5 less. That means I have to take 5 away from something. 5 less than twice the length, 2 times the length of side B. So A is B plus 6. A equals B plus 6. C equals 2B minus 5. And it doesn't say anything about side B, so we're just going to call side B side B. So A plus B plus C is 25. Well, isn't B plus 6 the same thing as A? And isn't 2B minus 5 the same thing as C? So instead of saying A, could I say B plus 6? And then plus B, well, we're just going to call B side B. And then side C, instead of calling it side C, can we call it 2B minus 5? I just substituted this value for A and this value for C, and that should still equal 25. I didn't change the value, I just substituted equal values into the equation. Well, look what the cool thing is now. We only have one variable. If we have one variable, this is so easy to solve. We're going to distribute a 1 here and here to get rid of our parentheses. So that's going to give us B plus 6. Then I have this B right here that I'm going to bring down. And then I'm going to distribute this 1. So it'd be plus 2B. Positive 1 times negative 5 is negative 5. And all of that should still equal 25 because all I did was distributive property. Can I combine like terms? You bet I can. This is a B. And this is a B, and this is 2 B's. B means that's 1 B, and this is 1 B. So I have 2, 3, 4 B's. And if I combine 6 positives and 5 negatives, I'm going to have 1 extra negative left over, and that should still equal 25. Okay. Do I need to get all my variables on one side? No, because all my variables are on the left-hand side. Now I need to isolate my variable. Well, here's my variable in this term right here. So I need to get that term alone. So I'm going to get rid of this positive 1 by using the substitution property of equality, which says if I subtract the same value from both sides, my equation is still equal. These cancel out. I have 4b, and on this side I have 25 minus 1 is 24. Divide by 4, and b equals 6. Well, let's go back to our triangle. B is 6. If b is 6, then A is b plus 6, which would be 6 plus 6, which would be 12. And C is twice b minus 5. Well, if b is 6, 2b is 12, and 12 minus 5 is 7. So if A is 12, and b is 6, and C is 7, I'm pretty sure that 12 plus 6 plus 7 equals 25. So I feel pretty good that we solved our equation. And we know what the lengths of each side are. And we know what b is. Sweet! Alright, I'm not going to do number 10 because I think you can do it. But number 11 has a whole bunch of fractions in it. So here's what we're going to do. 3x over 5 minus x over 4 plus 1/2 equals 6 over 5. If I keep all these fractions, that's just going to be a kind of a gnarly problem, but I know a way to get rid of my fractions. It's called fraction busters. I'm going to look at all my denominators. I have a 5, a 4, a 2, and a 5. And I know that if I'm looking for the least common multiple of these four numbers, I know that 20 is a multiple of 5, 20 is a multiple of 4, and 20 is a multiple of 2. And of course, 20 is a multiple of this 5. So if I multiply every stinking term by 20, every stinking term on both sides of the equation by 20, I have to multiply every term to keep my balance. That's going to make my fractions go away. 20 times 3x over 5 is 60x over 5. 20 times negative x over 4 is negative 20x over 4. And 20 times 1/2 is 20 over 2. And 20 times 6 over 5 would be 120 over 5. Now, each one of these numbers I can simplify. 60 divided by 5 is 12. That's 12x. 20 divided by 4 is 5, and it's negative. 20 divided by 2 is positive 10. And 120 divided by 5 is 24. Look at that. My my fractions are gone. Well, I did my distributive property up here. I'm going to combine like terms. 12 positive x's and 5 negative x's gives me 7x. Bring down my positive 10 equals 24. I don't need to get my variables on one side because they're all on the left side, so I need to isolate. Here's my variable. I need to get rid of those 10 positives. 7x equals 24 minus 10 is 14. Divide by 7. These cancel out, and x is equal to 2. I'm going to do one more because I want to show you how I justify my process. I'm going to do number 15, and I'm going to justify every step along the way. So, number 15 says 5 times the quantity x minus 1. Put this back here. Five times the quantity x minus 1 equals 2x plus 4 times the quantity x minus 1. Okay? Now, the first thing I'm going to write down is given, because this equation was given to me and I'm being asked to solve it. So every step that I take, I'm going to justify with some kind of an algebraic rule that allows me to do that. So the first thing I'm going to do is use the distributive property. To eliminate my parentheses, and I'm going to get 5x minus 5 equals 2x. 4 times x is positive 4x, and 4 times negative 1 is negative 4. I just used the distributive property. Now I'm going to combine like terms. So on the left side, these are not like terms, but 2x and 4x are like terms. So I'm going to combine those, and I'm going to get 6x and negative 4, and over here I'm going to get 5x and negative 5. Now, I know we combine like terms, and that was the justification for what we just did. Now we're going to get all our variables on one side, but I'm not going to call the rule get all your variables on one side, because what I'm going to do is I'm going to subtract 5x from both sides, and the rule that lets me do that is called the subtraction property of equality. And what that means is I can subtract the same value from both sides of any equation, and my new equation is going to be equivalent to the original equation. So if I subtract the same number from both sides, my new equation is going to be equal to my original equation. Okay, got all my variables on one side. Now I'm going to isolate my variable. Here it is. I need to get rid of the negative 4. How am I going to do that? I'm going to add 4 to both sides. And I can do that because that's the addition property of equality. And the addition property of equality tells me I can add the same value to both sides of an equation, and my new equation will be equal to the previous equation. So I'm not changing the value, I'm keeping my balance, crossing those out. X equals 5 negatives and 4 positives is going to give me 1 extra negative. And I plugged that in earlier and it actually did work. You can verify it. I think that's a great idea. Okay, we're done.